Longing for more space, open skies, and exotic travel? Then look up, about 30 to 600 miles straight up at the ionosphere, Earth's interface to space. Nestled far above the clouds but below outer space, this little understood destination invites you to explore its many features. Experience both the weather from Earth and the weather from space. Marvel at the ballet of radio waves and navigation signals, like GPS, leaping through this particle paradise. Sit back, relax, and take in the aurora, some satellites, and the International Space Station as they sail by. And you'll want your camera handy for one of the region's signature features, bright and colorful air glow. This daily show is made possible by the ionosphere's own swirling charged particles, because that's what the ionosphere is. It's all charged particles. During the day, enjoy the sea of particles, freshly energized by the sun. As the sun sets, this particle party relaxes and the air glow thins. Our quieter nightlife lets you gaze into clearer skies. The ionosphere is in constant motion, an amazing effect of space weather. Don't miss when solar storms rain down. The storm separates the particles even more, making this colorful region delightfully more dense in some places and stunningly sparse in others. And don't forget about storms from Earth below. Your weather from back home also stirs up this one-of-a-kind destination. Experience the unique beauty of every season, as changes in Earth's atmosphere, daily and annually, can create pressure waves, changing the ionosphere's shape and density. Venture to the equator, where our particles are packed in lush and thick. Cruise along a magnetic field line and see how the ionosphere's charged material also interacts with Earth's own magnetic field. Don't miss the superhighway of particles zipping out to space and back down to the planet. This unpredictable parade of charged particles can help you unplug and unwind. This is because the crowd of particles can garble the radio and satellite communications from home. The ionosphere welcomes you to discover more about this little-known region. After all, once you've explored this interface to space, who knows how much farther you'll be able to go.
Unexpected teleconnections in noctilucent clouds, presented by Science at NASA. Earth's poles are separated by 4 oceans, 6 continents, and more than 12,000 nautical miles. Turns out, that's not so far apart. New data from NASA's AIM spacecraft have revealed teleconnections in Earth's atmosphere that stretch all the way from the North Pole to the South Pole and back again, linking weather and climate more closely than simple geography would suggest. For example, says Cora Randall, AIM science team member and the chair of the Department of Atmospheric and Oceanic Sciences at the University of Colorado, we have found that the winter air temperature in Indianapolis, Indiana is well correlated with the frequency of noctilucent clouds over Antarctica. Noctilucent clouds, or NLCs, are Earth's highest clouds. They form at the edge of space, 83 kilometers above our planet's polar regions, in a layer of the atmosphere called the mesosphere. Seeded by meteor smoke, NLCs are made of tiny ice crystals that glow electric blue when sunlight lances through their cloud tops. AIM was launched in 2007 to investigate these night-shining clouds, to discover how they form, and to learn about their inner chemistry. As is often the case, however, when exploring the unknown, researchers found something they weren't even looking for: teleconnections. It's been a surprise, says Hampton University Professor of Atmospheric and Planetary Science James Russell, principal investigator of the AIM mission. Years ago, when we were planning the AIM mission, our attention was focused on a narrow layer of the atmosphere where NLCs form. Now we're finding out this layer manifests evidence of long-distance connections in the atmosphere far from the NLCs themselves. One of these teleconnections links the Arctic stratosphere with the Antarctic mesosphere. Stratospheric winds over the Arctic control circulation in the mesosphere, explains Randall. When northern stratospheric winds slow down, A ripple effect around the globe causes the southern mesosphere to become warmer and drier, leading to fewer NLCs. When northern winds pick up again, the southern mesosphere becomes colder and wetter, and the NLCs return. This January, a time of year when southern NLCs are usually abundant, the Ames spacecraft observed a sudden and unexpected decline in the clouds. Interestingly, about 2 weeks earlier, winds in the Arctic stratosphere were strongly perturbed, leading to a distorted polar vortex. We believe that this triggered a ripple effect that led to a decline in noctilucent clouds halfway around the world, says Laura Holt of the University of Colorado's Laboratory for Atmospheric and Space Physics. This is the same polar vortex that made headlines this winter when parts of the USA experienced crippling cold and ice. Holt took a careful look at meteorological data and found that indeed there was a statistical link between winter weather in the USA and the decline in noctilucent clouds over Antarctica. We picked Indianapolis as an example because I have family living there, says Randall, but the same was true of many northern cities. Cold air temperatures on the ground were correlated with NLC frequencies high above Antarctica 2 weeks later, she says. The 2-week delay is apparently how much time it takes for the teleconnection signal to propagate through 3 layers of the atmosphere, the troposphere, stratosphere, and mesosphere, and from pole to pole. It is a complicated topic, but this much is clear. NLCs are a valuable resource for studying long-distance connections in the atmosphere, says Russell, and we are just getting started.